So now everybody can hear me, yeah?
Yeah,
Okay.
everybody can.
Hi, everyone. This is Tony Van Dam. I'm talking to you from the United States, although my association is with the University of Luxembourg. And I'd like to welcome you all from all corners of the world to the webinar, the first webinar of this second version of the Copernicus MOOC. Now, this afternoon, morning, evening, depending on where you are, it's not only me that's going to be presenting. We will also, I'll start presenting, and my focus is going to be on the course itself and how you get your certificate. And then we'll have a presentation by Fabienne Jacques, who's the policy officer of Copernicus from the European Commission. And she'll take some questions for about 15 minutes as well. And then we'll have Anka Angalea, who's Earth observation and open data scientist at ESA, and she'll also take some questions. So you have three presentations for this webinar, and an opportunity to ask each of us separate questions. So this is, let's get started on my presentation. Do you see it? Does everybody, I can't see it on my screen. Fabian, can you nod if you see it on your screen? Ah, there it is.
Yeah,
okay.
I see it. That's okay.
Okay. All right. So, as I said in the videos, the MOOC is composed of 3 chapters made up of 12 different modules in each chapter. The first chapter has to deal with I don't know why this is taking so long for these slides to load. There aren't movies or anything in here. Please be patient, okay? The first chapter is called Understanding Copernicus Data and Services, and that'll be presented by myself and a colleague, Carlos. He'll present next week, and so those are 2 modules, and the idea there is that they'll introduce you to the Copernicus ecosystem. So I gave you a little bit of background. Carlo will tell you more about the dais and where you can download data to become involved and in the data processing. The second chapter is the biggest chapter, and it's made up of 6 modules. The name of the chapter is Learning from Success Stories. And these success stories introduce you to individuals whose startups are providing value-added services from Copernicus. These are really interesting slices of individuals that have been successful at finding value in Copernicus data and developing these products that other people can use. And then chapter 3, it's called Do It Yourself. It's made up of 4 modules, and they provide you some practical knowledge or tools that help you build Copernicus-enabled products and services yourselves. The idea behind this MOOC is to get you excited and give you the tools so that you can go out and also be an entrepreneur and build value-added services from Copernicus. The idea behind the MOOC is one of the goals of the MOOC for some people is to get a certificate. No, before I talk about the certificate, let's talk about what happens each week. As you have already seen, there'll be a new module each week that has videos, and I hope you've all seen the videos from at least the first module. There'll be downloadable materials, and these materials are usually there to help you dig deeper into some of the issues that are brought up in the videos. And then each week there'll also be individual work. It's 30 to 40 minutes of engagement by you all. And the idea behind this individual work is to allow you to understand whether you understood the material. It shouldn't take more than 40 minutes, but sometimes it could take a little bit longer. We apologize if it does. Just please be patient. And then finally, after each module, the video modules, there'll be a webinar that'll last 1 to 1.5 hours, depending on how many speakers we have contributing to the discussion during the webinar. The with this MOOC, you can try and obtain a certificate that acknowledges your participation in this MOOC learning. The certificate has certain requirements, and let's wait till my screen comes up here so that you can see the requirements. To get the certificate, you have to complete all of the modules in Chapter 1 and all of the modules in Chapter 3. So together that's 6 modules. And then you have to choose 3 modules in Chapter 2. Chapter 2, remember, has 6 modules in it, but we'd encourage you to watch all of the modules because they are quite interesting in and of themselves. What does it mean to complete a module? It means that you have to watch the required videos and complete the assignments. And as you see from Chapter 1, the assignments are quite moderate. It's not a huge obligation. And then finally, there's going to be an exam for the after all of the modules are finished. The exam is set up so that you will be tested on information that was provided in Chapter 1 and Chapters 3, and you'll only be tested on the modules that you complete or in Chapter 2. Now, passing the exam means that you need to get 70% or better on the exam, but you have access to all of your materials from the MOOC while you're taking the exam. So you shouldn't panic. Almost all of the participants of the version 1 of this MOOC passed the exam and received the certificate. So it's very, very doable. And then finally, I'd just like to wish you all, hope that you all enjoy what we've put together for the MOOC. We seem to have a very reasonable level of satisfaction from the first one. And I hope that the comments that we received in the first MOOC has allowed us to improve what we were presenting to you in the second MOOC. So now I'm ready to take questions from you all. If you write your questions in the chat, our associate at the Learning Center will start to go through them. And I'll answer what I can. But please try and, for my questions, focus on the structure of the course and the structure of the requirements, excuse me, for receiving a certificate. Thanks. Is it possible to access the course from a mobile? I guess it means, I think what you're asking is can you use your phone to access the course? And yes, if you can access I'm sorry, the website, if you can access Google or anything, another web server, then yes, you can access it from your mobile. I'm not sure I understand this question. What happens with the exam if you complete all of the modules? If you want to be tested, I think what's being asked here is what, if you can, for Chapter 2, if you complete all of the modules in Chapter 2, then you would be more than welcome to choose either to answer all of the questions from Chapter 2 or to just choose 2 of the modules there that you would like to answer questions to. I have a question here. What is the forecast to use Copernicus .eu portal be available? And this question should either go to Fabian or Anka, or you should hold this question until next week when Carlos is here to answer questions. This is beyond what I wanted to discuss, but thank you for your question. Yes, the webinars are all recorded and you're able to access them again through the platform, the Copernicus platform that we've established at the through the Learning Center. The assessments would have to be uploaded via the MOOC. In fact, the assessments are usually quizzes. They're not long questions. They're very short quizzes. So you do these assessments online. There's nothing for you to have to upload. Are the webinars mandatory to obtain the certificate? No, they're not. These webinars, the forum, these are for you to get to ask a question to the experts that have presented the videos for each module. So they're not mandatory. But we'd encourage you to participate because you might have a question that you don't know you have. Maybe just turn this on in the background. I have a question. Will we need specific software for the assignments? Will we process together Sentinel data? I know that for most of the assessments, no, you will not be processing Sentinel data. There's one module that requests that you download a specific type of open software to do some of the assignments. But we didn't seem to have any problem with that in the first version of the MOOC. So you're not going to be processing Sentinel data itself, but you will have to process some of the byproducts of the Sentinel data. Okay, I have a question here that says in the last version of the MOOC, there were problems for people outside of the EU. There were problems completing the assignments, which requires access to the ruse surface. Now, I can't answer that question, and I would ask that you hold that question for Fabien Jacques, who would be able to answer that question. I have a question here. Do we need to learn any program language to process the data? The answer to this with respect to the course itself is that no, you don't need to learn any programming language. However, if you're actually going in to process the Sentinel data, there is free software already available at the RUSE website so that you can download, so that you can get the Snap software to process the data. Certainly any post-processing of the data beyond the initial image processing or pre-processing, you'll have to figure out what data that is, and I'm sure you can do it in almost any language that you choose. I have a question here about students. Have students communicated and engaged with each other during the past courses? And the answer to that is yes. Through the forum, students can learn about one another and can ask each other questions and can try and learn what each other wants to do with the data, and even form partnerships to try and move further with the data. So I thought that was personally one of the most exciting things about the last version of the MOOC is the way that students were communicating directly with one another. And so I hope that in this version, you'll be able to take that as far as you like as well. I have a question here. Is the grade seen on the certificate? And no, this is a pass-fail situation. You get the certificate and it just says that you've completed all of the requirements. There won't be a grade on the certificate. Is it possible to retake the exam in case you fail? You know, I am not sure if this is possible. in my heart, I feel like it is, but I can't say that it is possible. If you ask this question on the forum, to me, on the forum, I will get this response out to you through the forum. Okay, we have a question. If we have a question for the speaker after the live webinar, can we submit it afterwards via email or via the forum? I don't think our emails are available for you all our personal emails are available to you all. But yes, through the forum, you can submit questions to each of the speakers. I know that during the first version that I responded directly through the forum to questions that were asked for Module 1. We have a question. Is it possible to pre-ask a question for the webinars, those of us who are not able to stay up late in our time zone? Is there a course page we can post questions if in a module you cannot pre-ask questions? Well, again, I would say that this is what the forum is for, is that I'm not sure if each speaker will look at the questions before the webinars, but we can encourage them to do that. And again, use the forum for any questions you have. If you have a question after you've watched the videos, but before the webinars, go ahead and ask the questions there. And our colleagues at the Competence Center will archive those questions, and we can try and answer them during the webinar directly. I have a question about what software skills will we learn from this course, and as I've tried to say before, this is not so much about teaching you software and how to process the data as much as this course is about introducing you to people who have been innovative and have produced some exciting projects from the data. If you the idea here is to get you all excited about this, about the possibilities for exploiting the Copernicus data. We don't have the time to actually teach you specific data processing skills. There are many other videos out there on through the Ruse and also on YouTube that show you how to process the data itself. I have a question. What about the activities in each module? What does it consist of? As I mentioned earlier, for example, in my module, you have the videos to watch, and then I provide some extra reading material for you to glance through. And the questions that I give you in my module are specifically related to either the videos or to the reading material. My questions, my quiz at the end of the module should really only take you about 30-45 minutes to do in total with the reading material. Now, some of the activities are a little bit more detailed, and you have to do some calculations. You have to do using the software that the lecturers tell you to use. So again, we didn't receive any complaints about those, so it's all very, very doable. And when it comes up, you'll see that it's nothing overwhelming for you to take on. Another question, will there be a notification email for future MOOCs? I think the MOOCs will be online, and if you have registered for this course, you will be informed. You'll get an email when the next chapter in the next module is uploaded for you to look at. You can go back anytime and look at the modules again. You can do them at your own pace. You don't have to do them weekly, but yes, you'll be notified for future modules. Now this question is asking about a future MOOC. In fact, this is the second version of the MOOC already, and there will not be another one after this. But I think the EU will archive this, and others will be able to access it. The webinars are. I have a question about when the webinars are scheduled. The webinars are scheduled at the same time every week. So if you're here for this one, then plan to be here for all of them. And again, if this is an absurd time for you, because we have people from almost every time zone that are participating in this MOOC, and I would suggest to access the recordings when you have time. Were there any success stories in the last edition? Yes, that's what chapter 2 is entirely about. I think your question is about the success stories that we present to you, and less about the success stories from the students themselves. I know that some people have taken the course and have moved forward with trying to develop their own ideas and their own applications and value-added products. So there are some student success stories. We haven't archived them, but yes, the MOOC has been successful in doing what we planned, what we set out to do. We have catalyzed interest in using Copernicus beyond what's already available. I have a question about being behind schedule if you haven't started module 1 by now. No, you're not behind schedule. The next module will be uploaded on next Monday, so you have plenty of time to go through module 1 and to be caught up. I have a question about the number of webinars for the course. Every module will have a webinar. So there are 12 modules. That means that there will be 12 webinars every Thursday. The lecturer or lecturers will be available and will produce a webinar. Do the tasks involve working, analyzing real data? As I said, this is not a MOOC that teaches you how to access the Sentinel data directly and to analyze it directly. There are some subtasks that have to do with accessing products. And yes, there you'll be analyzing some products, but we will not teach you how to process the Sentinel data. I repeat, if you want to process the Sentinel data, just do a Google search or go to YouTube, and there are many tutorials out there that show you how to process the Sentinel data itself and all the different kinds of data. We have not heard of, well, wait. Are there also unsuccessful stories so we can learn what can go wrong using Copernicus services and data? We do not have access to those stories. All I can say is, again, if you try and do something with the Copernicus services or data, there will be a name of someone that you can contact who can help you sort through your problem in most cases. But this is a rich data set. There are untried things that are out there as well. So don't be put off. If you get to a hard place, just keep pushing through it. The time frame, I'm being asked, what is for finishing a module before proceeding to the next one? That's 1 week. But remember, you can access this information anytime you want. So that if you're busy, then you can go back and finish a module. You don't have to do them in order. It should not take you more than, if you watch the videos and if you do the work, it should not take you more than 2 hours to finish a module, and that's without the webinars. I'm being asked, will there be any further courses for advancement after this one? As far as we know, our team this is the end of what we're supposed to, we were funded to do for this project. However, I'm sure that there is interest in developing further courses, and maybe based on the interest, we may move forward with trying to find trying to fund a different kind of course in the future, but that depends on conversations and opportunities that are made available through the EU itself. I have a question about providing proprietary software, and no, this is beyond our goal for the course, and it's if it's proprietary software, we cannot make that available to anyone. Sorry about that. I have a question about how many students registered for this MOOC, and I can't answer that exactly, but I think it's more than 1,100 students have registered for this MOOC. In the last MOOC, we had more than 1,300 in the beginning, and I think about 300 people successfully got the certificate from the MOOC in the past. That was it. In fact, those statistics were provided in the video that we produced for the first module. Are assignments from module 1 online already? Yes, they are. When the module is put online, it's put up as a block. So you'll have the videos, you have an entire handbook, and the handbook shows the videos. It gives you the what do you call it? The script from each of the videos, and it gives you the quiz is already there for you to take from module 1. So as soon as the module goes live, everything is available from the module for you to access. I have a question about the modules remaining online after the course is concluded, and in fact, I don't have the answer to that. If you, Francisco, if you ask this question through the forum, I will answer the question to everybody. I think I know I know that I can at least access the module, the MOOC 1 still, and I will ask the question about whether these will stay online and for how long they'll be online. Please ask your question through the forum, okay? Again, this question was asked earlier, is how many attempts do you have before completing the last exam to obtain the certificate? I don't know the answer to that. I didn't set up the exam, but if you ask this question in the forum, we will get this answer out to everybody through the forum. For these recordings of the webinars, no, I'm being asked if you'll receive them by email. No, you won't get these recordings through email, but you will be able to see the link of the webinars on the MOOC website. So in each module, you'll have access to the recordings. You won't receive a notification by email, however. Okay, I'm being asked about activities. I don't understand this question. You have the videos from module 1, okay? You have a quiz from module 1, you have additional readings from module 1, and those are all online, and then you have this webinar. So that's all the activities that you have to do from module 1. And it's like that for all of the modules. The work is not very detailed. Okay, I think we're at the end of the time for my question and answer. If you have more questions that were not answered, please send your questions through the forum, and we'll try and answer them there. Okay. Next is Fabien Jacques. Thank you. Bye.
Hello. Do I have to open my slides? No, it's done. Thank you. So it's my turn, I think. So I would like to say good morning, good afternoon, good evening, good night to everyone, because we are all around the world and we are traveling a lot with this MOOC. It's my first time. It's really a pleasure to see cool people around. Do you hear me well? Yes, that's okay.
I hear you, Fabien.
Yeah, that's okay. So let's move on. So you follow the first session of the MOOC, which is about really the discovery of the Copernicus program and to know more about it. I'm personally from the Commission, the European Commission, working in the Copernicus program since decades, I would say, because I started 20 years ago on GMES and I never stopped. And I'm still passionate by this program, so that's why I'm here. Rather than telling you again the story, I will try to sketch what could be the future and how you could use this program for your own sake, for science, for business, for any personal interest and whatever. So my talk will be really about now and next. So if I move to the slides, how do I do here? Just to go back very quickly to the story. Copernicus is a very old story. It's very old, but in fact that has been really a brilliant idea anticipating on what we really need and face today. So the idea came from a group of space agency and people working in Earth observation, but really concerned about the environment, the climate change already, what we could see from the natural resources and so on. And they decided to build, I would say, an Earth observation program that could remain stable in time, together with a really added value services that could help really people in using Earth observation data and making space useful, I would say. So the idea was in '98, and we conducted quite a lot of research projects in order to see what we could do with this data and in which kind of area where it was really needed and critical and feasible. And we reached a second step, which was in 2014, where the Copernicus program, initially called GMES, was created, meaning that the Commission and its partner, mainly ESA, we decided to commit to launch satellites and maintain them over decades, and to create public services which are completely open to everyone and completely free, both in Europe but also around the world. That's why we have so many countries around the table today, to support the development of environmental services and contribute to environmental monitoring, environmental conservation, security of goods and citizens, and so on and so forth. So Copernicus is really a set of satellites. It's Earth observation coming from space, but this is more than that because it's related also to delivering services to the community. So today we have a quite unique space capacity because we have already 7 satellites flying. 8th one is planned for early November this year. They are organized in families, and when we decided about these satellites, will it be Sentinel-1, 2, 3, 4, 5, 6? The plans was really to maintain this capacity of observation in time, meaning that the first one was launched in 2014. We launched a second one. We will launch a third one, a fourth one, and we are now deciding about maintaining this brilliant capacity after 2030, 2040. So it means that we really want to propose to everyone Earth observation capacity for at least 30 years, 40 years and beyond. So this is a really big step change in Earth observation to make it completely operational and accessible to all. So I was talking about the fact that Copernicus is not only about satellites. This is the main difference compared to the initial and old Earth observation programs that we had around the world. We sent plenty of Earth observation satellites already, especially for meteorology, which are extremely valuable. But in Earth observation, contrary to meteorology, we didn't have yet public services that can be easy to use. And so what we did is that we created these public services. As for meteorology, we had weather forecast services or weather predictions or climate projections. We tried to invent something similar, but on other areas, which are climate change, quite close to meteorology, but we are going beyond, about ocean monitoring, ocean observation and forecasting, which is new, about atmospheric monitoring, going beyond meteorology again, because we address the chemical composition of atmosphere, we address air quality. Then an area where Earth observation was already quite well demonstrated and useful was about the land use monitoring, the land cover. And so we tried, in fact, to make that completely systematic and operational to provide reference information in terms of land use and land cover, which are really generic products of high interest when you want to work on urban planning, spatial planning, agriculture, on the use of land and on the protection of land, which is an area where quite a lot has been done already and quite a lot still has to be done. We have also 2 services which are a bit different because these ones are not completely open, since they are really focused on security. These 2 services are made for public organizations like firemen, like coast guards, like financial agencies and so on, to deal with the security of goods and citizens, for the border control, for the maritime surveillance, maritime safety at sea, for the support of EU in the external action, like for humanitarian aid. And then we have a specific service which is dealing with emergencies, big emergencies, major natural disaster, and where we are working directly with the civil protections, in fact. So apart from these 2 last one, all the services are completely public, open, free, so that you can use this data and these products for it, and to all, going beyond Europe. And we have plenty of partnerships with countries around the world, so that we can share and exchange all of that. Clearly, these services, even if designed in 1918, are really there to support the environmental transition. So now I will move on to the future. In fact, we are currently preparing the future of Copernicus because we have placed a new space regulation for the next financial framework program of the Commission from 2021 to 27, and to cover the EU priorities in terms of policies and implementation for the next MFF. I try to move to the next slides, but I can't reach it here. So Copernicus is a user-driven program, but this is also a policy-driven program, and this is an EU program. So the first priority of Copernicus is to tackle the top priorities of the European Commission and the European institutions for the next period, 2021 to 27. So our president of the Commission, Ursula von der Leyen, introduced a very big challenge to be implemented by the next Commission, which is the Green Deal. What is the Green Deal? The Green Deal is really a game changer so that Europe become a climate neutral continent in the next decade, up to 2030, 2040, 2050. The Commission has completely endorsed the fact that the climate change is something really at stake, both for our environment, but also for us. It's driving our safety, it's driving our economy, it's driving our social comfort, I would say, and our work and everything. So it's really something extremely important that we have to face, to tackle, and to adapt for it so that we can reduce risks related to climate change and we can enjoy our planet in the future. Therefore, in the Green Deal, she has defined a set of priorities on which we should work in order that the EU is in well shape, that EU citizens and EU industry and EU scientists and so on can better live and progress during decades to come. And if it's EU oriented, I think it can have a global impact around the world to benefit all the countries also, so that they can benefit from what we do openly for their own engagement and their own priorities. Inside the Green Deal, you have plenty of things. Improve the transport to develop green transport, less polluting. We have a very strong commitment to zero pollution in the future, in the ocean, at sea, in rivers, on the ground, in soils. We really want to preserve the biodiversity and recover from biodiversity loss also, which is really, really important. It's important also for economy and for social life that we support rural areas, little cities and so on, leaving no one behind the progress, so that it's equal and fair for everyone. And it has impact, for example, to define a new agriculture policy calling from farm to fork, meaning farming, agriculture is not only a business, this is also food security and this is also well-being. That's why we need to modernize all of that, including the impact on small farmers. We need also to transition our cities to make smart cities, to have affordable energy and also clean energy. So this is the overall package of the Green Deal, and a very ambitious package, I would say. Since Copernicus is an environmental program by essence, it's for us fundamental that the Copernicus services, the Copernicus satellites, the data are defined, evolves towards these goals, so that everyone can be an actor of this goal. So what next for us? So what we have in terms of ideas for the development of Copernicus, for the EU competitiveness, for the EU Green Deal, and for the world challenges and world well-being, is to progress on different priorities, which are pollution, which are conserving our cultural heritage, because this is something also important, taking care of forests, because forest is a key component of the CO2, the carbon cycle, and decarbonization also. We have to take care of our poles, Arctic and Antarctic, because what is going on there is critical for our lives at cost, but for biodiversity, for shipping, for plenty of things. So this is extremely important. The use of land is still very, very important. We will keep working on that to improve. Carbon, I was talking about it. We are deeply engaged in the implementation of regulations and solutions to comply with the Paris Agreement and go beyond. So the monitoring of CO2, anthropogenic emission of CO2 is very, very important so that we can reduce in time this emission and recover of the current situation. So this is something quite new and important that will develop in Copernicus with a dedicated service, a new one. Renewable energies, clean energies, very important. The monitoring of the coast and helping coastal development and coastal conservation is also equally important. Maritime security is also a priority, maritime surveillance, and water also in general. All of that are priorities that are given in public regulation and communication from the Commission, and mainly the space strategy and the new space regulation adopted this year, and for which the budget is under final negotiation. To do so, we have sent satellites in space already. We will continue to send satellites in space, and we have more than 20 satellites planned in the current generation of Copernicus, and we will have 20 more and more for the next generation of Copernicus to be launched between, I would say, now and 2030, 2032, and to live until 2040, 2045 at least. So it's really a big ambition, and for that we expect to have around 5 billion euros to make it and to achieve it. So that's the scope of the future of Copernicus. For you to come back to the MOOC and to come back to you and your expectations and work. So Copernicus, this is really an ecosystem and a family. This is 28 countries. This is plenty of people from different skills. This is operational, but this is also linked to research. We have jobs behind, enterprises, public institutions. All of these people are working and cooperating and exchanging, following the same line, which is extremely important. And so in the Copernicus program, it's important for us to support also research, innovation, business development, because all of that is positive towards the goal that we have, which is now the Green Deal. So therefore, in the Copernicus program, okay, you have satellites and you have services, but you have also tools to help you developing your ideas, your science, your business, or your passion. Until now, so we are in the middle of nowhere because we are in between the two programs 1 and 2. So up to now, we used to have a startup program dedicated to people like you that wants to create something from Copernicus. And in this program, we have different tools that were able to help you, like Copernicus Masters, Copernicus Hackathons, Copernicus Accelerator and Incubator, so that you can learn from Copernicus, but you can also be accompanied, like the MOOC today, and plenty of other actions from which you can benefit. At the time being, we are, I say, in the middle of, at the end of this phase. So these tools, for some of them, are finished and closed. And we have to wait until 2021 to 2022 to reopen this kind of facilities for you. In the meantime, if you need help, if you want to continue to work on Copernicus and help, you have at least two groups of people that can help you, which are the Copernicus Relays and the Copernicus Academy. The Copernicus Relays, this is people in each country talking your language that can help you in using Copernicus or being in contact with Copernicus services or the Rus or whatever. So relays are only implemented in EU countries. It's not worldwide, but in some other countries you can have national contact point also in other countries across the world. And then you have the Copernicus Academy, which is a network of universities and schools that can that teach Copernicus. Not online, but with real courses and real graduates behind. So these people are still available for you. In parallel to, I need to move my slides. Okay, this one. This is my last one. In the meantime, so you have the MOOC where you can play with the data. It's a first contact and so on. If you want to go beyond, if you want to move on and do more with Copernicus, so you can access the RUS service in ESA to access to Sentinel data and be helped. You can also play with the Copernicus services. They have all a service desk where they can answer to your question, they can help you in developing applications, and where you can find plenty of use cases and success stories of what can be done with the Sentinel data and with the Copernicus services. And if you want to go beyond in terms of accessing the data, ESA, EUMETSAT, ECMWF, and Mercator, which are partners of Copernicus, have created what we call DIAS functionalities, DIAS services. DIAS meaning data and information access services. So these DIAS platforms, which are listed here, which are Soglu, Honda, Wikio, Creo DIAS, and Mundi, this is cloud platforms, web portals, where you can find access in one point, all Sentinel data and all Copernicus products in one stop shop, okay? Together with cloud computing capacity, so that you can easily compute this data without downloading this data, without moving them directly on the cloud, using these facilities provided by Copernicus. So I engage you to use these kind of tools because it's quite easy to use Copernicus data and products on to develop application on that, and you can also find examples of what can be done. So that's it for me. I wanted to introduce which tool you can have to work today and what is your future, so that you can also imagine what you could do afterwards. And so you have a few keywords. What is really important for us is to go beyond space and tackle problems which are non-space and which are not from our communities. Be inventive, work together, help adapting to climate change, introduce social science. All of that is important for all of us. That's it for me. Is it okay?
Up to 6.
Or still online because I have no feedback. So I try to answer to the questions which are popping up. I'm in Panama. Is there a contact point near here? Okay. We have a partnership with the US, so maybe it's close. We are in discussion with Panama to have an agreement with them, but we don't have yet a contact point, an official contact point there. Is it possible to create value-added products based on Copernicus free data and commerce it? Yes, for sure. That's the purpose. Yes. We really want to create business from Sentinel data and Copernicus products. So you are most welcome to use this data and create value on top of it to sell it. What it's not allowed is to sell this data without change, because these data are free. But once you have created value, yes, I hope you will create business from it. Does the GIS data have implication within the context of buildings and cities? Do you have some business cases as example? Yes, this data can be used in the context of buildings and cities. We don't have a very high resolution, but in the land service, Pan-European land service, you have urban atlas and data that you can use for business case, and we have some. So maybe you can look at the land service web portal or in the, I think on the ESA website. where you can find business case like for civil engineering, building subsidencies, things like that. Any issues about using RUST services outside EU in order to complete modules? I'm afraid I cannot answer to you because I'm not familiar with the use of RUST outside EU, but my colleague from ESA, Anka, may answer to you. Is there any freely available hyperspectral sensor data? Not yet. We don't have any hyperspectral mission flying on Sentinels. There is one hyperspectral mission in the plan, but that will not fly before 2028 or 2030. In the meantime, you have commercial hyperspectral missions that are not free of charge and not Copernicus. Is there a link overview where to access data? Yes, you go to copernicus.eu and you will have access, an access point to all Copernicus services, and then you can go to ESA website where you have the RUST service. Copernicus.eu. When will vote and confirm the budget for Copernicus do? Very nice question. The sooner the better. We hope that the budget may be voted by the end of the year and latest end of quarter one to 21. But hopefully this year. What is the current resolution of the Copernicus data and is going to be improved in the future? Current resolution depends on the satellite. For Sentinel-1 can be around, and depending on the modes, from 30 meters to 300 meters. For Sentinel-2 can be 10 and more. For Sentinel-3, it depends on the sensor. In general, all the resolution will be improved in the future for the next generation of satellites. Yes, it will be. Non-European citizens could access and use data to create business opportunities? Yes. It's open to the world. It is possible to make a patent or IP on the algorithm which processes Sentinel data. You can make the patent on the algorithm that you develop on top of Sentinel data. You cannot make any patent on the processor of Sentinel data, which are used by and funded by the Commission and that are producing the Sentinel data today. So all the algorithm that you create on top of what is delivered by Copernicus is yours. Can you support economically or provide some guide to looking for grants or subsidies to implement business? Copernicus under Horizon 2020 and the next research program, Horizon Europe, will still maintain open call to support market development. So it exists since years, where you can bid for grants to develop your business, but you have to demonstrate of research and innovation. It will be continued. We don't have subsidies as such. It's grants. And then if we maintain the hackathons and so on and incubator, you can also use this kind of tool. How long does it take to get a Copernicus relay point? We applied a month ago and still no answer. Ooh. You should send back a mail to my colleagues. I don't know. But again, we are really at the end of the organization of Copernicus 1, and so that's why maybe it's long, but it should be done. Come back to the Commission to ask for. Does satellite data exist in thermal infrared or is it programmed? So thermal infrared, we have a bit of thermal infrared already flying on Sentinel-3 DSL-STR instrument, which is used for SST and land surface temperature. In addition, we are studying with ESA a new Sentinel instrument, which is a thermal instrument that may fly not before 2028, but this is not yet decided if it will fly or not because of budget constraints, like for the hyperspectral. So it has been studied, it's not yet decided. Will be decided not before end 2021. What is the best way to access historical data captured by Copernicus? So historical data, it depends. If you want data which are less than 1 year, it's online. If you want data which are older than 1 year, 2 years, you need to ask for a dedicated download, either to the Copernicus service in charge, either to ESA, because it's the long-term archive. The long-term archive is accessible, but you have to ask for. It's not purely online. It's too big. We are talking about petabytes.
Well, Fabienne, don't hesitate to post them on the...
Questions?
Sorry? And now we will give the floor to Angelia. So, Anka, you can
I
activate
think if
your
there
mic.
is no more question, maybe this is Anka to
Yeah.
take the floor. Yeah.
Anka,
Thank
you
you.
can now activate your camera and your microphone. Yes, okay, it's loading.
Hello, can you hear me now? Hello?
Okay, we cannot hear you. So you can start your presentation, and Fabienne can now deactivate her camera and her microphone as well. And we will
Okay.
give you the floor.
Okay, thank you so much. So you can see and hear me well, I suppose. I no longer see my presentation, but perhaps, yes, now I can. Okay, perfect. So good afternoon. Okay, my presentation disappeared. Oh, it's back. So good afternoon, everyone. It's really a pleasure for me to be here. And my name is Anka Angela. I'm an open data scientist working in Earth observation for the European Space Agency. I'm based in Frascati, in a very small town close to Rome. This is where we have our establishment. It's called ESRIN, our establishment. And today I will give you a brief introduction into what ESA is, what is our role in Earth observation, and what is the connection with Copernicus. And hopefully I will manage to give a bit of context to the presentation that you've seen before, and maybe also to the lectures that in the videos that you've watched for this first module. So I'll just get started. I will briefly introduce ESA. You are from all over the world, so probably you don't have a lot of information about what ESA is. But ESA is the European Space Agency, and as we call it, it's Europe's gateway to space. It's an international organization that brings together 22 member states. It is not the same as the European Union or the European Commission, although we work very closely together and we address, let's say, a similar objective, which is to bring benefits to the European citizens. The 22 member states of ESA are not exactly the same with the members of the European Union, although most of the European Union is part of ESA. We have 5,000 employees, so we're quite a large organization, but out of these we have, let's say, 2,300 employees that are ESA staff, and the rest are being contracted to the European industry, and they provide on-site expertise where complementing basically our expertise. The scope of ESA is the exploration and use of space for exclusively peaceful purposes, and we have our headquarters in Paris and another 7 establishments scattered all over Europe. And of course, a spaceport in French Guiana in Kourou, and we call this Europe's, let's say, access to space. So it's the port from which we fly our satellites and we put our satellites into orbit. Our budget is around 6 billion per year, and you can understand that there are almost 85% of this budget goes back to the European industry that we contract to build new technologies and provide new services based on the space assets that we have, and of course on the Earth observation data that we receive from our satellites. So to get a feel of how much European citizens are getting back and how much they're benefiting from the results that we are producing, it's a cost of around 12 euros per European citizen per year. So this is the contribution for which we believe, let's say, the benefits are quite high, and it's quite an exciting field. So what does ESA do? Well, of course, I mentioned that ESA brings together 22 member states, and it relies heavily on the very good collaboration and cooperation between these member states. Unlike other national, let's say, space agencies, ESA is active across all areas of the space sector and is a world leader in science and technology. And when I'm saying that we're active across every area of the space sector, I mean navigation, space transportation, space exploration, human space flight, Earth observation, of course. So basically all the fields, all the activity fields that are related to space science and technology. We have over 80 satellites developed, tested, and operated since 1975. This is when ESA was established. The establishment of ESA, or the idea, came actually a lot before, but ESA was, let's say, launched and established through the merge of two different organizations, the Space Research Organization and the Launchers Development Organization. So these two merged in 75 and ESA was formed. And we've had over 220 successful launches from, as I was saying, Europe's spaceport, which is based in Kourou in French Guiana. So who benefits from this? Well, this is probably why you're here, because you believe you may have a benefit out of Copernicus and out of using space assets and space data, let's say, or data delivered from space. Indeed, citizens are the primary, let's say, beneficiaries of all the activities that we do. If you think only about TV, broadcasting, the precious weather forecasts that we all rely on, but also navigation and data access. And this is, I left data access at the end because it's a really important point to think that Copernicus offers all the data fully open and fully free for everyone on the globe to access. So this creates a huge potential for not just for business, but also for learning and development. Secondly, it's our economy that benefits from this. If you think just about all the jobs and the services that are being created on top of this space assets and space industry, let's say. Third is our planet, and of course Copernicus is the flagship Earth observation program of Europe, and it delivers near real-time, is the largest, let's say, operational service delivering near real-time data about our planet and about its climate. And finally, it's our future that benefits from it, thinking that millions of young men and women are attracted to start a career in space, in earth science, and in general, let's say, ESA is an inspiration, drawing people to look more into STEM, so science, technology, engineering, and math. Focusing on Earth observation, from our perspective in ESA, Earth observation is covering, let's say, a range of different types of systems that look at our planet from very different perspectives, and they have very, very different goals and objectives. And I will just review some of these. We have, on the one hand, the Earth Explorers, and these are our science missions, and they address really critical and urgent challenges that are being put forward by the scientific community. We have missions that look at all the Earth system science spheres, let's say, from missions that look at the Earth's gravity fields, such as GOCHE. So these are, let's say, historical missions, or missions that look at the Earth's water cycle. We have SMOS, missions that look at how the Earth's ice sheet evolves and what are its dynamics. We're talking about Cryosat here. The very innovative constellation that is called SWARM, looking at the Earth's magnetic field. We gain information about global winds from Aeolus. And of course, we have, let's say, upcoming missions that will help us gain a better understanding, for example, on the Earth's forests, Earth's biomass and the carbon cycle through the biomass mission, or information about how healthy is our vegetation, and we get an information about this through photosynthesis or through looking at photosynthesis processes, and this will be the role of the FLEX mission. So this is let's say the science context and examples of our science missions. We have, of course, meteorological missions that are built in partnership with EUMETSAT, and actually some of the sentinels, some of the upcoming sentinels will be, let's say, hosted on some of these meteorological missions, such as METOP second generation or the Meteosat third generation. Finally, Copernicus, getting to the point, Copernicus, as I was saying, is Europe's flagship Earth observation program. It's made to provide us with global monitoring for a safer world. Copernicus is a joint partnership, let's say, between the European Commission. It's a program led by the European Commission, supported by the European Space Agency, and us as a space agency, we're responsible with the implementation of the space component. So Copernicus is an operational Earth observation program. It responds, of course, to some of the most stringent and most timely needs of Europe and its society and its citizens, which is the need for accurate, let's say, and reliable geospatial information services, providing at the same time autonomous and independent, and this is very important, access to information for our policymakers. You've heard a lot in the previous conversation about policies, but particularly for environment and security issues. And this is where all the Copernicus services come into play, and all the entrusted entities with implementing and delivering these services come into play. ESA, as I was saying, is responsible with implementing the space component, and the space component refers to the actual satellites. So the satellites are, of course, you've heard this word a lot, the Sentinels. There is a fleet of Sentinels already in space, and there are plans to expand this fleet of operational satellites. There is Sentinel-1. Sentinel-1 is a radar satellite. It currently consists of a pair of satellites, Sentinel-1 and Sentinel-1A and Sentinel-1B, that were launched in 2014 and 2016. This is a mission that is providing very valuable information about our lands and about our oceans. Sentinel-2 is a multispectral satellite. Again, is formed of a pair of two satellites, Sentinel-2A and Sentinel-2B, which were again launched at 2 years difference, 2015 and 2017, and they've continuously delivered information about mostly about the land. So it's mostly a land applications mission. Sentinel-3 has a suite of instruments on board, but is primarily, I'd say, aimed at ocean forecasting, environmental and climate monitoring, and again consists of two satellites, Sentinel-3A and 3B. We have Sentinel-5P, or Sentinel-5 precursor, in orbit, that is providing us with very precious atmospheric information about our atmosphere. And we're looking at Sentinel-5, Sentinel-4, as well as Sentinel-6 upcoming satellites to be launched. Sentinel-6 is actually planned to be launched on the 10th of November this year, and now is being prepared to be transported to the launch site. As I was saying, I'm based in Frascati. Frascati is the small town that hosts ESA's Center for Earth's Observation. It's called ESRIN. We call it ESA's Eye on Earth because this is where we do all the activities related to the exploitation of Earth observation data. So all the operations and exploitation of our Earth observation satellites is done here. We also oversee from ESRIN the world's largest database of environmental data for Europe and Africa. And we do a lot of interesting things in ESRIN, and I will just give you a glimpse of what can be done. There are so many applications that you can imagine with this plethora of data that is being available in that is being delivered. Well, I will say daily because of all the satellites that are orbiting the Earth. But I will just give you one example of a practical application to give you a taste of what you can actually do with systems that have been put in place to exploit and to facilitate the exploitation of Earth observation data. These are actual businesses that have created the necessary infrastructure. You've heard about the DSs. The DSs are the Data Information and Access Services. So they've put together all the cloud infrastructure, the processing infrastructure, together with the tools to process the data. And this is what you can do with these tools that have already been put in place. One of the initiatives that we launched this year during, we all know what the context in which we're living today with the pandemic that has affected the globe. And one of the initiatives related to this is called the Rapid Action on Coronavirus and Earth Observation. And this is a joint initiative between the European Commission and ESA to provide the world with timely information, actual information about how this pandemic affects our daily lives. Everyone is interested to know how it spreads, what are the effects on our health and so on. But there is a very strong economic impact. There's a very strong environmental impact. There's a very strong impact on agriculture. So all the activities that have been put, let's say, on hold, they show, let's say, and we can see this from space, and we can see this with the Sentinels. And I will show you how. So you can actually see it by yourself. This is a dashboard. It's an open system. You can access it as I'm presenting, actually, if you go to race.esa.int. So this is a dashboard that is using Earth observation data from the Copernicus Sentinels primarily, and third-party missions as well. And it communicates the effects of the lockdown on the environment and on the economy, as I was saying, as observable from space. We use actually all the satellites, all the Sentinels that are in orbit right now. I will give an example of how we use each of them. So with Sentinel-1, as I was saying, this is a radar satellite. It has a synthetic aperture radar on board, and this is very useful kind of measurement if we want to look at the variation let's say, dynamics of activity in different, let's say, key economic points. This is an example of the impact on steel industry. Steel industry or steel production sites are quite a good example or good sites to monitor with Sentinel-1 data, because they produce, well, steel. And in general, the intensity of the radar signal that is measured through a satellite such as Sentinel-1 is higher if it's reflected by metals. So this enables us to see, okay, is there a variation in the signal? Is this variation above or below a given average or a given baseline? Well, we can see that. In the picture in the middle, you can see one of these steel production sites located in Sweden. And the green box is actually marking the logistic area where the output production is being stored, is being deposited. So assuming that you would have, let's say, a normal production cycle, you would see little variation in the signal. But as the production goes higher, then you would see a much higher energy in the signal, or as the production goes low, you would see much lower energy in the signal. And this is what you see on the graph on the right side. And this is very valuable information, because steelmaking is a critical industry for Europe. Europe is the second largest world producer after China. So you can actually build a service to provide information on how steel production, for example, as an industry is doing in a certain part of the world, just by using this free and open data. And this is how you add value. And this is something that you can build a business out of. With Sentinel-2, well, this is an optical satellite, so we look at different things. Sentinel-2 has 13 bands. It has different resolutions in these bands. But the highest resolution is 10 meters. And with this resolution of 10 meters, you can see quite a lot of things. If you think about ships, ships that transport materials, or ships that transport, let's say, oil, these are quite large. So you can see them quite fairly easy in Sentinel-2 data. So you can use Sentinel-2 data to see how the commodity markets are doing. If as we do in this example on our dashboard, we look at specific piers in ports where we know that such large ships can stop. So they bring and they take away the imports and exports of such materials. So by looking at the presence of ships and by counting, let's say, if this number is higher or lower than average, you can understand if there has been a decrease or if there has been an increase in the activity in that area. And this can be, of course, is not an absolute measure, but it can be an indication if things are happening just as before the pandemic or something has changed. With Sentinel-3, normally we look at the sea. So this is, as I was saying, it has a lot of instruments on board, but it's useful to measure sea surface topography, sea land surface temperature, and ocean and land surface color. And in this example, we look at the water quality. The picture on the left side shows that a blue dot in the Venice Lagoon, or very close to Venice, in Venice Bay, North Adriatic. And we can look at how the chlorophyll A concentration has varied in time, and we can compare this with the climatological mean. And again, if the values are higher or lower than a climatological mean, then we can derive that the water quality is worse or better. And we can plot this in a graph just like this, and you can actually access this graph if you go at the link that will be available in these slides. So you can look at the graph and you can understand how much for a given day when the satellite has passed and we have a measurement, how much chlorophyll concentration is there in that point? Is it higher? Is it lower? Is it within the standard deviation? And this gives us precious information about water quality. My final example refers to Sentinel-5P. And thanks to the Trupomi instrument on board the satellite, we can look at, we can collect a lot of information about our air quality, about the ozone layer, about climate. And in this particular case, we're looking at the variation of NO2 concentration, so nitrogen dioxide. Now we know that this is an important factor that can affect human health. So we're mapping with the Sentinel-5P air pollution worldwide. And we can also derive, let's say, similarly to how we treat water quality, we can also derive time series related to NO2 concentration. And we can see on the graph, as you can see here in the graph on the left-hand side, how this concentration varies through time. Of course, there are a number of factors that affect this concentration. Some of the most important factors are the changes in the weather, so changes in wind speed, cloudiness, etc. They all affect these measurements that we take. But if we average, let's say, across 2 weeks' time, we can partially take out this meteorological variability, and we can understand that there is actually a human influence. So all the car traffic, for example, has a large contribution to NO2. And we can derive such information. And we saw actually a decrease in the NO2 concentration during the lockdown because there was less traffic on the streets. So these are just few examples of what you can do and what you can derive out of the Sentinels that are already in orbit. As I was saying, this platform and this dashboard that you can freely access, and actually you can contribute to it. It's open in GitHub, so you can have a look there. This platform was built fully on infrastructure that is available worldwide. So it's something that you can use. It's mainly supported by the Eurodata Cube, which relies on the DSs, on the Creo DS and on Mundi DS. So you have a lot of resources to start a business, let's say, on top of the data that is provided by the Sentinels. This concludes my presentation. I hope that I've raised your appetite, let's say, to start exploring Sentinel data. And I really hope that you are ready to discover more. Thank you.
Don't hesitate to post them on the chat, and we would display it on the screen.
Okay, I have a question about accessing the Rust services from outside EU in order to complete modules. Well, to be honest, I'm not really involved in the practicals of this MOOC, but I know that the Rust services have been interrupted. So the virtual machines are no longer running. I do not know what is the plan with relaunching the virtual machines, but I do hope that someone from the that is responsible with the practicals of the MOOC can give you a hand with this. However, I can encourage you to go to, so you can download a lot of open source tools that we make available. You have the Snap that is available and you can download freely and you can process Sentinel data. You can of course go to other services that are available for free, at least for research purposes, also on the Eurodata Cube. You can explore through the Sentinel Hub. So there are several resources. I'm not really sure about the Rust, I'm sorry, but I do hope that you will be able to receive answer to this question. Okay, so I have another question on what would be the simplest workflow suggested for someone with some computer science skills, but no experience in geosciences, as a sensible approach to get something done from Copernicus data, even that thing is very basic and not original at all. Okay, so there is one thing that you could try. We have launched a number of competitions. They're called custom script contests, and they are supported or initiated by ESA in partnership with Synergize and with the Sentinel Hub. So I encourage you to have a look at these competitions, because there you have access to some very basic scripting capabilities, and you have all the data already available. So have a look at the Sentinel Hub and the custom script contest, and you can start from there. You can look at the examples that were done, or the examples done by other people. And you can see who was the winner of the competition, so the best ideas that were selected. Normally, these are very basic ideas that are being submitted, so this would be a good place to start. Can the satellites also observe rip currents in the sea? I'm not sure I can answer this question. I'm not really an oceanographer, so I don't know what exactly what is a rip current in the sea, but I do know that with Sentinel data, with Sentinel-1, for example, you can get information about ocean currents, and waves. So yes, you can observe currents in the sea. Yeah. Can you give more examples about the usage of these huge data provided by Sentinels? Well, if I go back to the examples that I've presented before, all these are from very different domains, let's say. So we have impact on economy, but you can look at various industries, not just steel industry, the one that I presented. You can look at a lot of different things. You can monitor, for example, forests. You can provide valuable information for the management of a forest, for example, or you can look at agriculture, providing information about crop yields. This could be valuable for insurance, for example, or for public agencies that are providing subsidies for this. So the applications are really they're out there. So whatever you can imagine is, I would say that the sky is the limit in terms of what you can do with this data. Apart from Snap and BRAT, are there any other softwares available to process Sentinel-3 data? Well, this is a good question, but again, with this service that was put in place on the Eurodata Cube, you can explore what would be, let's say, some of the free workflows that are out there. So there are a number of free, so open notebooks that you may want to have a look at, and you can see what kind of workflows can be done. But as long as you have, let's say, access to a processing infrastructure, which is provided by the DSs, and access to the data, which is again provided through the DSs, basically you have everything you need. For an integrated software, I'm not really sure.
Okay, Enka, we can accept one more questions, if it's okay for you.
Sure.
Okay.
Okay, the question is, are tools, for example, to extract efficiency or measure heat in the cities? Yes, heat islands in cities. Yes, we have actually projects that are looking into this. Well, the tools, as I was saying, are the same. All you need to do is just to see what tools are available on the DSs and what data is available on the DSs. But I do encourage you to have a look at our webpage. It's called EO4Society with a 4 as a number, .esa.int. And there you can find the projects that we finance on heat islands. Yeah.
Thanks a lot, Enka, and thanks a lot to all of our speakers and our participants for the first session of the second edition of Copernicus MOOC. We hope you all enjoy it and that you can make the most out of it. If some of your question hasn't been answered yet, don't hesitate to post them on the forum on Moodle, and we wish you a nice day, evening, night, wherever you might be.